Lesson 12 is solving linear systems by elimination. And we've learned so far how to solve by graphing. That's when you graph the two lines and look for their intersection point. We've also learned the substitution method, which is when you substitute one equation into the other to solve for your variables. And then with elimination, our goal is to eliminate a variable in order to solve for the remaining one. So 12.1 is adding two equations. Example 1 is solve the system 5x plus 2y equals 10 and 7x minus 2y equals 2. So when you're solving by elimination, what we're looking for is we want there to be two or like a pair of variables in each equation that have the same coefficient, which a coefficient is the number in front of the variable. So like right here I have a 2 and a 2, and it's even better if they have opposite signs. One is positive, one is negative. So when that's the case, there's a property that says, we can just add two equations together. And if we add two equations together, these two are the same number, 2y and negative 2y, just opposite signs. So they're going to cancel each other out. Because if I do like 2 minus 2, 0, or a positive 2 plus a negative 2, that's 0 also. So that's what we're going to do. We're going to set up the equations like an addition problem. So draw our little like kind of equal sign line, I guess. I never really thought of what that would be called. And then our plus sign. And what we do is we just go left to right and we add each term. So first, 5x plus 7x. When you add like terms, you just add the coefficient, the number in front. So 5 plus 7 is 12. And then the x stays the same. And then next, negative 2y plus, 2y, positive 2y, and then plus a negative 2y is 0y. So this would be like plus 0y, but 0y is just 0, like it has no value. So we don't have to write it in the equation at all. So I'm just going to leave it out completely. And if you wanted to like kind of cross it off, you could also, if that helps remind you to not have to write the y in the equation. And then we bring down our equal sign, and then we add 10 plus 2, which is 12. And then now I've kind of accomplished what I set out to do, which is get to an equation that only has one variable. I only have x, so now I can solve that equation. So this is a 12 times x. So I want to get x by itself. So in order to do that, I have to undo multiplying by 12. So I'm going to divide by 12 right here. And then I have to do the other side of the equal sign also. So 12 divided by 12 is 1. So that cancels out. And then I'm left with x equals 12 divided by 12 over here. Remember, if it's like the side that does not have the variable, we wouldn't cross it off. 12 divided by 12 is 1. So we end up with x equals 1. And then remember that when you're solving a system, if you think about when we solve by graphing, we're looking for the intersection point, which a point is x and y. So we found the x, we just need to find the y now. Same approach as with substitution. You pick one of the original equations, whichever one you want. I'm going to use the first one. So I'll rewrite it over here. 5x plus 2y equals 10. And then we take that 1 that we just got for x and we put it into that equation for x and solve for y. So this would be 5 times 1 and then plus 2y equals 10. And then 5 times 1 is 5. Bring down the plus 2y and bring down the 10. And then from there, my goal is to solve for y. So I want to move everything away from it. So I have a 5 that's being added to it, and I have a 2 that's being multiplied by it. So first I'm going to get rid of the 5 that's being added to it. I'm going to subtract 5, since this is a positive 5. And then I have to subtract 5 from the 10 also. So 5 minus 5 is 0. And then I have 2y equals 10 minus 5 is 5. And then from there, still same goal, trying to get y by itself. So as a 2 times y, so to undo multiplying by 2, I would divide both sides by 2. 2 divided by 2 is 1, so this becomes 1y, but we don't need to write the 1 in front. And then 5 divided by 2, we can't divide it evenly, so you can put it as 2.5. I would probably prefer it as a fraction though, so I'm going to leave it as 5 halves. So that's our y value. So we have our x and our y. So together our solution would be 1 5/2. And remember, you always write the x part first when you write a point. So 1, 5/2, and then in parentheses. And then remember, with systems, you can check your answers pretty quickly. So I'm just going to show one check on the video. I'll show this first one. So in order to check your work, you pick one of the original equations. I use the first equation right here for when I solved for x. So I'm going to use the second equation for my check. So for the check, I'll write it over here, 7x minus 2y equals 2. And then I'm going to take each of my x and y values and put them into that equation. So x was 1, so I'll put that there. And then y was 5/2, so I'll put that there. So this will become 7 times 1 for x, and then minus 2, oops, forgot the minus 2 times 5/2 for y, and then equals 2. And then from there, I need to multiply the 7 and the 1, so that's 7. When I multiply 2 times 5/2, if you ever just really aren't confident, one thing that you can do, because you can do this with a calculator technically, if you change this 5/2, if you did 5 divided by 2, that's 2.5. And then you could take the 2.5 and multiply it by 2. So that's one way to get the product, which is just what happens when you multiply two things. The other way is, if you want, you can think of this as 2/1. And then so it's kind of like a fraction times a fraction now. So the 2's can cross cancel. And they would both become 1's. So then I would just have 1 times 5 in the numerator, so that would be a 5. And then 1 times 1 in the denominator, so that would just be 1, and I don't need to write that anymore since it's just a 1 in the denominator. And then equals 2, and then 7 minus 5 is 2, bring down the equals 2. So the check works as long as you get the same number on each side of the equal sign, which is what we did. So it just is kind of like validating that we did get the correct answer. Okay, example 2. Solve the system y equals 4x plus 7 and negative y equals negative 4x plus 3. So looking at the system, it kind of looks like the problems that we use for substitution, and this wouldn't be a bad problem to use substitution as your method. We're just going to use elimination since we're practicing it here, but when it comes down to it, you ultimately have the decision to decide, and if you decide you like one method more than the other, for problems like this, you can decide which way you want to go about it. Okay, so we're looking for a pair of variables that have the same coefficients. It looks like I have kind of two pairs. So the y's, one is a positive 1, one is a negative 1. For the x's, there's a positive 4 and a negative 4. So when they're all kind of matching, there might be some funky things happening, but it's okay, we'll figure it out. But we have at least one pair of matching, which is what we need to eliminate a variable. So we're ready to go ahead and add the two equations together. So we'll set it up like an addition problem, and then we'll just go left to right. So first is I keep switching the order. First is y plus negative y. So this is a 1y, this is a negative 1y. So to add like terms, you just have to add their coefficient. So 1 plus negative 1 is 0. So notice for this one, I didn't cross it off. That's because if I cross it off and I don't put something there, because that's the only thing that's on the left side of the equal sign, it would really mess up the structure of the equation. And then next is 4x plus negative 4x. So a positive 4 plus a negative 4 would be 0x, but we don't really need to write this one now. And I'm going to go back. Notice how I didn't write 0y here. 0y is just 0, so you would never really put the variable for 0. At most, you would just put the 0 itself, and that's just kind of a placeholder in this problem for that left side of the equal sign. And then over here, 4x plus negative 4x, that's 0x, because 4 plus negative 4 is 0. But it's just 0, so we can just cross them off. It just kind of wipes itself out. Kind of like if you were using inverse operations, a positive 4 and a negative 4 added together would be nothing. And then over here, 7 plus 3 is 10. So we kind of ended up with one of those funky answers. We got some of these in substitution. So where, all the variables are eliminated, which we maybe could have guessed that would happen based on what we had originally, and where there was like kind of two pairs that were matching but opposite signs. So they were going to cancel each other out. But either way, we ended up with 0 equals 10. All the variables are gone, and 0 definitely does not equal 10. That's not true. So when all the variables are gone and it's not a true statement, that's when it's no solution. And then remember, when the variables are gone and you end up with two numbers that do equal each other, like 10 equals 10, that would be the infinitely many solutions. Okay, so 12.2, multiplying one equation by a constant. A constant is just like a regular number without a variable or anything like that. So like 4 or like -2, or it could even be like a fraction, like 1/2. But it's just a number that is like, the word constant means to stay the same. So it's a number that is itself, it's not changing. So example 1, solve the system -3x plus 2y equals 7 and 6x plus 5y equals 13. So in 12.1, we were looking for matching coefficients. So we'll try to find those here. So you notice like the x's, those aren't matching because one is a 3 and one is a 6, or -3 and 6. And then the y's aren't matching either. One is a 2 and one is a 5. So they're not matching. That doesn't mean we can't use elimination. We just have to make some changes to the equation before we can. So if I look at my like -3 and 6, those are like factors, or not factors. They're 6 is a multiple of 3, or 3 is a factor of 6 technically. But what I'm getting at, besides rambling, is that I can take 3, and if I multiply it by 2, that gives me 6. Or if I take -3 and I multiply it by 2, that would give me 6. So that would give me the matching number. So in order to do that, I just have to take the entire equation and multiply it by 2. So you're allowed to do that as long as you multiply every single part of the equation by 2. So we'll do that, and then we'll rewrite the new equation on the right. So it'll be 2 times -3, which is -6x, and then 2 times 2y, which would be 4y. The variables don't change at all, just the coefficients, the number in front. And then I can't forget my equal sign next. And then this next part gets forgotten so much. You got to remember to multiply all the way on the other side of the equal sign. So 2 times 7 equals 14. So that's my new like first equation. And then for the second equation, that was the one that had the -6, or sorry, 6x, not negative. So I just need to copy that over because I don't need to make any changes to that one. So I'm going to copy it over as 6x plus 5y equals 13. It's the same exact equation, so no changes need to be made. And then now I'm ready to go ahead and set up my addition problem. And then from left to right, and one more time, just really quick. So the reason I'm ready now is because now I have those matching coefficients. One is -6, one is +6, and since they're the same number but opposite signs, if I add them together, it would be 0, and it would wipe out that x. Okay, so left to right, -6x plus 6x is 0. I don't need to write the 0 because there's some other stuff on this side of the equal sign, so I'm just going to cross it off. And then 4y plus 5y would be 9y from 4 plus 5, and the y part stays the same. And then I would bring down my equal sign, and then 4 plus 13 is 27. And then now I have this equation that just only has y, as it's like one variable, so I'm able to solve for y. So I have to get it by itself. This is a 9 times y, so to get y by itself, I'll divide both sides by 9. 9 divided by 9 cancels out, it's just 1, and then I'm left with y equals 27 divided by 9 is 3. So that's one part of our answer, is y equals 3, and then don't forget there should always be two parts for a system, x and y. So you can pick whatever equation you want in order to solve for your other variable, solve for x in this case. I'm just going to go ahead and use the second equation this time. So 6x plus 5y equals 13. And then like I said, it doesn't matter. You pick whichever one you feel like is easier for you. In this case, the second equation had some bigger like numbers to work with, but the first equation had a negative to deal with. So it's entirely up to personal preference. So next, we take the y equals 3. We put that in the equation where y is. So it'd be 6x plus 5 times 3 for y equals 13. And then now I need to multiply the 5 and the 3, so it'd be 6x plus 5 times 3 is 15 equals 13. And now everything on the left side of the equal sign is simplified, meaning I did multiply the 5 and the 3. So now I'm ready to start isolating the x and getting that by itself. So this 15 is being added to it, so to get rid of that, I would have to subtract 15 from both sides. And then I would bring down my 6x. And then 15 minus 15 is 0, so that cancels out. 13 minus 15 is negative 2. So when you have like one is positive, one is negative, you find the difference between the two numbers, which is 2. And then you would take the sign from the bigger number. So like 15 was bigger and it was negative, so this was a negative 2. And then from there, we're trying to get x by itself. Now there's just a 6 being multiplied by it. So to undo that, I'll divide both sides by 6. 6 divided by 6 is 1, so that leaves us with just 1x, but we don't need to write the 1 in front. And then negative 2 over 6, that's my answer, but it can be reduced, so we should reduce it. Both negative 2 and 6 are divisible by 2. So I'll divide both by 2, and then negative 2 divided by 2 is negative 1, and 6 divided by 2 is 3. So that's the other part of my answer. And then I just want to write my final answer as a point, like in parentheses. So it'd be negative 1/3 first, because that was x, and then 3 second for y in parentheses. So our solution is negative 1/3, 3. And then same thing here, like it doesn't change by problem. You can always check it. I just don't want to check every single one because that would give you like a really, really long video. I don't want to do that to you guys. Okay, so example 2, solve the system. This is like a really good point to maybe pause the video and see if you can do example 2 on your own, because it's really similar to example 1. So it'd be kind of a good point to like check your understanding so far. If you need another example though, of course, you could just do it with me as you watch the video. Okay, so example 2, solve the system negative 5x plus y equals 7 and 10x minus 2y equals negative 14. Okay, so for this one, we want to get the coefficients to match up. So if we kind of compare them, there's a negative 5 and a 10. So negative 5 and 10, it looks like maybe I could double the negative 5 to get 10. Another one is y and 2y. So this is, remember, 1y. So if I double 1, I end up with 2. So I'm just going to go ahead and take the whole first equation and multiply it by 2, since it looks like both variables in that first equation. If I multiply it by 2, or sorry, both terms with the variables, then I would get matching coefficients with the second equation. Okay, this may end up being one where all the variables cancel out, and that's okay. We'll talk about what those solutions look like once we finish. So I'm going to take the first equation and multiply it by 2, either because I want this negative 5 to become a negative 10, so those match up, or I want this y to become a 2y, so those match up. Does not matter which way you look at it at all. So this will become 2 times negative 5x. 2 times negative 5 is negative 10, and then the x stays the same. And then 2 times y should be 2y. And then don't forget about the very end, 2 times 7 after the equal sign would be 14. And then the second equation stays the same. We don't need to make any changes to it. So 10x minus 2y equals negative 14. And then from there, we can add the equations together, so we can set up our addition problem. So left to right, negative 10x plus 10x is just like a 0, because negative 10 plus 10 is 0, and the x's just wipe out. So if you want, you can put a 0, or you can cross it off for now. And then the next term... I didn't get that. Ooh, could you try again? Sorry, Siri thought I was talking to her for some reason. Okay. No need to apologize. Ah, okay. Sorry. Anyways, 2y. I'm gonna start back. Okay, so the next term, 2y plus a negative 2y, 2 plus a negative 2 is 0. If I just go ahead and cross this one off, then I have nothing on that side of the equal sign anymore since the equal sign is right here. So since they're both crossed off, I do need to just put a 0 there as a placeholder, or else it would really mess up the structure of the equation. So both of those canceled out. That's totally okay, but I do just need to leave a 0 there so we have something on that side of the equal sign. And then on the far right, 14 plus negative 14 is 0. So my variables all canceled out, and I was left with 0 equals 0, which is true. So that means that there's infinitely many solutions. Okay, so we talked about an example 2 from the first section. All the variables canceled out, and we had like a statement that was not true. We had 0 equals 10, so if it's not true, it's no solution. Here we had 0 equals 0, which is true, so it's infinitely many solutions. And then last section, 12.3, this is when we have to multiply both equations by a constant to get them to match up. So we want to check for our matching variables or matching coefficients. So I have a 3 and a 5, so those don't match. And then I have a 4 and a 6, those don't match either. So what makes this kind of like our third level of difficulty here is if we think about it, I can't just change one equation. So for example, if I wanted to take the 3, I can't really multiply 3 by like a whole number to make it equal 5. I would have to multiply it by like a fraction. It would be like pretty funky that way. And then same thing with the like 4. I can't multiply 4 by any sort of like whole number to get to 6. And unfortunately, we can't just like add to the equation. We have to multiply the equation in order to keep the same value. So when this is the case, you have to multiply both equations. So it takes us back to like the least common multiple. So the least common multiple is the smallest number that a pair of numbers will multiply to, for lack of better terms. So first we just need to pick, okay, which numbers do we want to match up? It doesn't matter which one you pick, you just have to pick. So I'm going to say I want the y's to match up. So if I want the y's to match up, I'm going to find the least common multiple between 4 and 6. So for 4, the multiples are 4, 8, 12, 16. Because it's like 4 times 1, 4 times 2, 4 times 3, 4 times 4. And then for 6, the multiples are 6, 12, 18, and so on. So I'm finding, this is the LCM, which stands for least common multiple. So we made the list of multiples. Common just means the one that they both have. So we have our multiples, we have the ones they both have. Now we need to find the smallest one that they both have, which is 12. So 12 is the least common multiple. That's what we're going to try to change the coefficient of y into. The only other thing that we need to consider is every other problem that we've done up to this point, the coefficients have had the same number, but they've been different signs. So like this was a negative 6x, this was a positive 6x. This was up here, a positive 2y and a negative 2y. We always want that to be the case. There is a different way where if they're the same sign, you can subtract, but it's a little bit easier to make mistakes that way, so we're just going to stick with keeping the opposite signs. So let's say I want to change that 4y into a 12y. I have to think, okay, 4 times what gets me 12? I would have to multiply by 3. So I'm going to take this entire equation and I'm going to multiply it by 3. And then I'll write that new equation over here. So it'll be 3 times 3x, which is 9x. 3 times 4y, so 3 times 4 is 12y. And then the equal sign, and then we can't forget about the very, very last term, which is the 8, so 3 times 8, which is 24. So that's my new first equation. And then I need to change this 6y into a 12y, but I want it to be the opposite sign of my other 12y, so I want it to become negative. So that means that I can't just multiply this equation by 2, because 2 times 6y would give me 12y, and I need it to be a negative 12y. So I have to multiply that equation by a negative 2. Anytime you need to change the signs of something, you need to multiply by a negative. So we'll distribute. Negative 2 times 5x is negative 10x. And then negative 2 times 6y is negative 12y. And then the equal sign. And then don't forget about the last term. Negative 2 times 12, or sorry, negative 2 times 12 is negative 24. Okay, and then from there, before we add on, just double check. So our goal was to get like the y's to have matching coefficients but opposite signs. So one is a positive 12, one is a negative 12. So we're good. We kind of set out what we were trying to do, and then now we're ready to add the two equations together. And by the way, we could have it would have been the same outcome if we had done a negative 3 and a positive 2 instead. It doesn't matter which equation you make negative. I just did the second one since it was the second one that we multiplied. So it's totally up to you to pick whichever one. Okay, so now from left to right, we'll add 9x plus negative 10x. 9 plus negative 10 is negative 1. So negative 1x. For now, I'm just going to leave the negative 1 there. I know I don't have to, but I'm just going to leave it. And then between 9 and negative 10, if we have two different signs, like one positive, one negative, that we're adding together, just find the difference of the two numbers, which is 1. And then you take the sign from the bigger number. So like 10 was the bigger number and it was negative, so our sum was negative 1x. And then the next one, 12y plus negative 12y is 0, which that's the one we were trying to cancel out. 12 plus negative 12 is 0. The y's go away. We bring down the equal sign. And then 24 plus a negative 24 is 0. And this one we wouldn't cross off because that would leave us like nothing to put down below. We just put 0 there as a placeholder. 24 plus negative 24 is 0. And then if you recognize, okay, this means x has to be 0, you can kind of stop at that point and just write that. But if not, we're trying to solve for x, and there's a negative 1 being multiplied by x. So I just need to divide by negative 1 to cancel it out. Divide over here by negative 1, and then negative 1 divided by negative 1 goes away. I'm just left with x equals 0 divided by anything is 0. And hopefully, this may look confusing because you may think, oh, it's undefined, but it's when 0 is in the denominator that's undefined. So if you see 0 in a bottom of a fraction, it would be undefined. 0 on top of a fraction is just 0. So we'd end up with x equals 0. And then that doesn't mean no solution or infinitely many solutions, because we still have a variable that is the value for x. It's 0, and that's totally okay. So we still have to find y. So in order to do that, I'm going to take that x equals 0 and put it into one of the original equations. I'm going to use the first one. I'm going to use the ones that we had before we made them. We changed them, like when we multiplied by 2 and then, or negative 2 and 3, just because I have smaller numbers to deal with, so I might as well use just the original. So 3x plus 4y equals 8. I'm going to take that x equals 0 and put it into the equation where x is. So 3 times 0 is 0, plus 4y equals 8. 3 times 0 is just 0, so I don't need to write 0, I just kind of cross it off, has no value. And then I bring down my 4y equals 8, and my goal is to solve for y. Right now there's a 4 that is being multiplied by y, so to undo multiplying by 4, I would divide by 4. 4 divided by 4 is 1, so this is just a 1y left over, and then 8 divided by 4, 2. So we have x equals 0 and y equals 2 as our final answer. We just want to write it as a point, 0 for x, 2 for y.